Okay, at the very top, I'm going to go over a review concept with you on net versus total distance, because that is the most common accumulation function on the A/B test, or perhaps the most popular one. So I'm going to bring you guys back to a test question that you had before, where there was a bug crawling and they give you guys an image. It was a former AP test. And let's say that you're given the velocity curve and time here. And there's going to be certain things that I'm just going to give you guys rather than we calculate the area of this trapezoid, just as a demo for review of what we've learned already. So you guys have a trapezoid, then you have a little bit of a triangle that goes underneath, and then another triangle that goes above. And again, don't worry too much about like how it looks, just those geometric shapes are good. Doesn't matter how big, how small, whether it makes a full line or not. And I will tell you guys certain key points. This time right here is 4. This time right here is 6. And then the end of time here is 8. Okay, so we're given a velocity function, curve, sketch of a curve. And let's say that you know that integral represents area. You went on to calculate the area of this trapezoid with 6. The area of this triangle, and remember when we say area, it's the area that is between the curve and the x-axis. So 10 would be this trapezoid. 4 would be between the x-axis and the triangle that dips below. And then we're going to say this is 5. Okay, so when we say what's total distance, remember that when we refer to total distance, let's write that above here. Total distance can be found in one of 2 ways, right? We can either split the integral up. If we didn't have a calculator, if we're looking at a curve, total distance would be 10 plus 4 plus 5. Okay, we can't, when we represent that in an integral, we're going to do it one of 2 ways. We're going to integrate from 0 to 4. And then how do you guys make this area that dips below here positive? If I'm integrating, how do you make it positive if you're going from 4 to 6? What could you guys do to make an area that is negative positive? You can, okay, you guys can switch it. Good. You could switch the 4, sure. So you could go backwards. You guys can also, how do you guys make a positive, or sorry, a negative number positive? You can multiply it by a negative. Good. So splitting the integral such that you have the integral from 0 to 4 positive, but the integral from 4 to 6 negative, and then this integral positive from 6 to 8, since it's already positive above the x-axis. So that's one way. The other common way of looking at this is if I want to make something negative, I can also take the absolute value of the entire thing, of the entire velocity function. So if and when you guys have a calculator, what you're going to do is interpret it as the absolute value of the entire velocity function. If we don't have a calculator, we have to break the integral apart and find out where it dips below the x-axis and force or negate that into being positive. Okay, versus net distance. Net distance is easy. Net distance is what a regular integral does. If I go straight from 0 to 8, the integral from 0 to 8, that's going to get me net distance, which means it's going to tell me what my displacement is, that I've walked forwards. Let's say you're thinking about walking forwards 10 paces, you go backwards 4 paces, and then you go forward 5 paces. And then where are you at? Or how much has your position changed? That's displacement. So that's net distance. And that is just the regular velocity function. Now, one curveball that they're going to throw that we've seen maybe here and there is that they might give you guys an initial condition that that the position function isn't necessary, or your position isn't necessarily 0. You don't start off with just 0. Let's just say that you calculate after you've traveled 5 miles already, and then you start your timer at that point. Okay, so S of 0 equals 5 means that your position at time t equals 0 is given as 5. Okay, so sometimes they'll ask you guys, well, then can you tell me what your position would be after 4 seconds? Okay, so what is your position after 4 seconds? So if you've already began with 5, you guys know, okay, well, does this mean I have to integrate velocity to find the position function to find my displacement? Okay, so technically you can do all of this if you have a calculator or a graph without necessarily integrating. You can use it you can calculate this using the area between the curves, like what we're going to do with this problem, or you can input the whole thing into a calculator and come up with your position at time t equals 4 without necessarily doing the integral yourself. So let's say for this one, if I want my position at 4, I'm going to take the fact that I started off with a position of 5 and add my displacement. My displacement being, since my initial starting position was at time t equals 0, I'm going to find and accumulate the distance that I've traveled, the net distance. So I'm going to go start from 0 and go to, in this case, they want 4 of my velocity function. Okay, so again, this is displacement. So I'm going to go back to my graph from 0 to 4. I've traveled forwards 10 paces. I'm just going to say paces or miles. So it's 5 plus 10, which is 15. Okay, can you guys go ahead and calculate and type into the chat, what is your position after 8 seconds? What is your position after 8 seconds? Go ahead and calculate the numerical value for that and type it into the chat. And don't forget, you guys have the initial position of 5. Okay, good. Yeah, all those coming through are correct, you guys. 16 is the correct answer. 5 plus displacement. Displacement being net integral, net distance. So you guys can see the area above the curve was 10, the area below 4, and then 5. So we're going to subtract out 5 because that means I went back 4 and then I went forwards 5. And then don't forget you started off with 5. This value, I forgot to mention this in the other period, so I'll probably upload this video. For this time doesn't always necessarily start off at 0, meaning that they could give you guys an initial position that might be like at time t equals 2. So if that was the case, then we can also find S of 4. If they gave me S of 2 is, let's say, 7, then I would just replace this with 7. And my starting lower limit of integration, since I only have to accumulate from time t equals 2 to time t equals 4, this would change to 2. So whatever that value time is that they provided here, that's what we would start off as. Because this first page is review of that type of concept, I'm going to skip over this. I'm confident you guys can figure this out on your own. I'll provide answers to you guys so you can check your work. But it's just reviewing particle motion, given velocity, when is it moving right and left. So displacement, total distance, and net distance. So good for you guys to just kind of go over that. Again, I wanted to do a more complicated free response with you guys live in class, and then the ones that you guys have to follow are very similar. So these are very common A/B questions of a free response. You can also look up the scoring guide eventually if you are doing the homework and you want to know how it was graded. The year is given to you, so if you search that year, you should be able to find that scoring guide. So once again, integrating velocity gives you guys net distance at the top of the next page, and integrating absolute value of velocity gets you guys total distance. That's the most famous type of accumulation function, is your velocity function. However, rates can be representative of anything. So here they talk about something interesting. Let's say that you guys were, so velocity is not the only rate. You guys can be given functions that represent a different type of rate. So velocity is miles per hour, if you think about it, but basically the change in distance over change in time. Here, it's the number of tickets that a police officer gives each day per hour. So the moment you guys see number of something per something, for velocity, it was per mile, this is per hour. If you end up integrating that rate of change, you're always accumulating whatever the total number of, so in the case of velocity, total number of miles, in this case, total number of tickets over that 24-hour period, over that time. And the time here is each day. So below here was the 2005 one. Can I have you guys take a minute and read the top? So you guys, this is kind of like giving you velocity and asking you guys to calculate certain things about position afterwards, but instead of accumulating miles, you're accumulating the amount of sand. There's two rates of change given to you guys, the amount being removed, so the amount being added. And then you'll also notice I highlighted, this is important. I want you guys to underline that anytime you guys are given these types of questions, because that is your initial amount of sand, kind of like your initial position. Okay, so at time t equals 0, the beach contains 2,500 cubic yards of sand. Pay attention to units of measure because they also always will ask you guys to indicate units of measure for most of your problems, which could be worth a point for the full free response or a point within that part of that free response. So how much sand will the tide remove from the beach during the 6-hour period? Okay, can you guys type into the chat, which function would you guys be integrating, R of t or S of t to answer this question? And what do you guys think your limits of integration would be for it? So what is the function, S or R? And then what are your limits of integration? Okay, when the good, so a lot of you guys have RT coming in, and 0 to 6 for the 6-hour time period that it's accumulating, the amount of sand being removed. So now, one thing I'm going to note, so some things I'm going to recommend to you guys, if the function is already defined as R here and as S here, you guys can use that function without having to necessarily write out the entire function again within your answer. So again, in a free response, if the AP test already has those functions written for you guys defined as R, you guys can simply just write your expression as such. And then this is a calculator question. Please do not try to integrate functions that are on the calculator portion. You're going to utilize your calculator to integrate this. Even though you could do this one, you cannot do this one. So therefore, just trust me, just do that part of it on your calculator. So if you forgot where to find this, can you guys go ahead and enter in? And it doesn't hurt for you guys to write, okay, I'm going to put Y1 into R2, or sorry, RT into Y1. So keep note of where you're inputting certain things. You don't have to do it on the AP test, but it helps if you guys end up needing it later on. So ensure in R of T, make sure that your mode in this class is always in degree mode. Oh, sorry, radian mode. Your AP Physics class will always be in degree mode. So make sure your mode is on radians. You're going to enter in this function into Y1. You're going to accumulate or integrate using math 9, the function under math 9. And then can you guys type out your answer to 3 decimal places? What did you guys get for this? Okay, good. The ones coming through are correct. And then also include in your answers your units of measure as well. What is it that you're accumulating and what is it measured by? If I move too fast or if you didn't get the answer and you guys want to know what went wrong, I'm going to suggest if I move past a problem and if I don't get to your questions and it doesn't, it's not working out to where it's exactly to 3 decimal places, please take a picture of it on your phone of the of your home screen and of the Y1, Y2 screen, so I can see where it is that you made the mistake. But very nice. Many of you guys, or all of you guys typing it in, got 31.816 cubic yards. Or I'm going to say the other acceptable answer would have been 31.815, where it was truncated after the 5. Truncated means you just cut off the rest of the significant digits after 5, and then you just included the 5 without rounding. That's okay as well. If you guys go more than 3, it's fine as long as it's just right. If it's wrong, then they mark you wrong. So 3 is the minimum. And then you have to include units of measure, which is cubic yards. So perfect for that. And For part B, now they want us to write an expression for y of t, the total number of cubic yards of sand on the beach at time t. So now we have to take into account that sand is not only being removed, but it's being added by this pumping station, by the function s of t. So if they want the total number of yards at a particular moment in time, first we're going to say y of t. I'll help you guys out with this one. Okay, so what is it that we began with? What's the initial amount of sand that we had on the beach before anything was removed or added? So good, there's gonna be that amount that you guys always have to take into account. Okay, so at time t equals 0, if nothing else, we have 2,500 cubic yards of sand. After that, sand started being added and removed. So it's an accumulation. So if you guys look above here, when I wanted to accumulate something, I would stop at the time at which I wanted to consider. So here, so that time is generalized to be t. So my limits of integration are going to go from 0 to t. So here, typically this, if you have a variable defined here, it's going to be different from the variable that is within your integrand. So I'm going to switch the variables within my integrand to be x instead of t, just because in theory, what you're going to do is integrate with respect to whatever the variable is, and then plug t in. So then it is an expression in terms of t. So as a generalized variable, we'll just use x here. So we're going to add the amount of sand that is being pumped into the beach, which is your s of t function. But instead of t, I'm going to call it x. So s of x dx. Okay, would you guys want to add the amount of sand that is being removed, or would you want to subtract the amount of sand being removed? Would it be addition next or subtraction? So we want to subtract the amount of sand that you are removing from the beach so that we can get a live idea of how much sand is on the beach, right, in current time. So 0 to t of r of x dx. So again, if you think about this, this is saying that you have 2,500 cubic yards of sand. You're going to add this amount that's accumulated from 0 to whatever that time is, and then subtract out the amount of sand that's being removed by the tide. Okay, and this is your expression in terms of t. Now go to part C. For part C, it says find the rate at which the total amount of sand on the beach is changing at time t equals 4. I like to underline certain things. This is asking for a rate of the total amount of sand. So what is it that they want me to find the rate of, and what is a rate? So when I think of rate, I think of it's a derivative. Okay, total amount of sand. Well, the total amount of sand was the function above, right? The y of t represented the amount of sand on the beach at time t equals blank. So in this case, they want me to find the derivative of this function of y of t. Okay, so we take the derivative term by term of y prime of t. What is y prime of t? What is the derivative of 2,500 of the first term? What's the derivative of 2,500? Okay, the derivative of a constant is just 0, so that's not going to matter. Okay, so it's just 0. Anyone recognize this concept here? If I ended up taking the derivative of an integral, what is that testing you guys on? The derivative of an integral. Very nice. FTC. They kind of cancel each other out. FTC part 2. So if I'm taking if I'm integrating something, then taking the derivative, I'm reverting back to the original. So if I take the derivative of an integral, lower limit is a constant, upper limit is a variable. All I have to do is plug the variable into your independent variable inside your integrand. So this is going to end up being s of x, and the derivative of t is just 1, so we don't have any to worry anything about the chain rule part of it. Minus, again, term by term, so minus the derivative of this integral, so minus r of x. And they want to know, oh, sorry. Yeah, I'm sorry, you guys. I did the whole variable incorrectly. It should be s of t minus r of t. Thank you. S of t minus r of t. We're plugging the t in for x. Okay, so then from there, they want to know, find the rate of change at time t equals 4. So we're going to calculate y prime of 4 as s of 4 minus r of 4. So currently, you guys have stored in your calculator r of t as y1. And so I remember that because I looked back and I saw that's y1. So now, since I need s as well, I'm going to enter in s of t into y2. So can I have you guys go to your y1 screen or y equal screen and enter in s of t is equal to 15t over 1 plus 3t, making sure that when you guys enter it in, you guys are putting parentheses around your denominator. Once you guys have that done, we're going to try as much as possible to keep things calculations clean by entering them in on your home screen as variables. So for this, you do not have to write this on a typical for response. I'm just writing this out because I want you guys to have it in your notes, or since you guys can't see my screen for the calculator. But on the home screen of your calculator, after you've already entered in y1 and y2, s of 4 would mean that you guys can just do y2 of 4 and then do this all in one step, y1 of 4. And then tell me what you guys get for that. What's y2 of 4 minus y1 of 4 out to 3 decimal places? Okay, good. The ones coming through are correct. Okay, perfect. Since I'm getting quite a few coming through, it's negative 1.909, or if you guys had truncated, negative 1.908 is also acceptable. And units of measures are cubic yards per hour, since it's a rate of change. Very nice. Okay, part D is on this one, and I think the next one is the hardest question because of the amount of stuff that you do have to calculate for this. So I'm going to highlight a few things and just mention it to you guys as important for closed interval. Okay, so that's going to be the first thing that I'm going to do. This is a review concept, but still important. I'm just going to circle that, highlight it, and say closed interval, and then I'll mention something about that. Okay, so closed interval. At what time t is the amount of sand on the beach a minimum? From what you guys learned in the past, when I'm calculating a min and a max, what do I need in order to calculate a min or a max? Okay, good. We're saying critical points. We need critical points, which is when the first derivative is equal to 0, right? So we're going to go back to reading this question again. It says, at what time is the amount of sand on the beach? So the amount of sand on the beach is your function. Your function, therefore, is y of t. The amount of sand is y of t. So they want to know when y prime of t is equal to 0. Well, we just calculated y prime of t from above, right? Y prime of t is in part C. Y prime of t happens to be s of t minus r of t. So then my critical points, so this is for critical points, would occur when s of t minus r of t is equal to 0. How do I solve this on the calculator, you guys? How do I find s of t minus r of t equals 0? Okay, graphically, I can set s of t equal to r of t if I add r of t to the other side. That is now, what functionality are you guys using on your calculator to calculate s of t is equal to r of t? Good. If you guys are thinking intersection, can I have you guys go ahead and calculate the intersection? And this is where some people had some difficulties with the answer being exact. So if you guys can do the intersection, and keep in mind, this is a closed interval from 0 to 6. So I know for my x's that I don't need to look at any intersection points beyond 0 to 6. So if you want to change your window size so that it's 0 to 6 for x's, and focus in on where it's intersecting just within that time interval. So when is S of t equals to R of t, which is S of t was your y2 and y1. And if you guys can type into the chat, what is the time equal to? We always are concerned with what the x value is of that intersection. Okay, as you guys are finishing that up, I'm going to emphasize this. This is not the answer. This is a intermediate step. This is the time at which there's a possible critical point that could represent where my minimum occurs. So since they're asking for when is the minimum on a closed interval, what else do you guys have to consider? When you have a closed interval for mins and maxes, what do you guys have to consider? Okay, so yeah, maybe in where I wrote that closed interval, right? Also consider endpoints. Okay, so you want to consider endpoints. So that means that a first derivative test is not going to be sufficient because you have to consider the endpoints anyway. So whenever they say justify your answer on a absolute min or max type question, what I'm going to do is go back in and think about, well, which one is my absolute max or min value? The only way to calculate that is to actually find what the value, min and max value of your amount of sand is. So if I go back to, well, what is my amount of sand? My amount of sand is the function y of t. So table of values with y of t, we have to consider 0, we have to consider 6, and then my intersection point of 5.118. Okay, so if you guys do first at 0, we already know the answer to that, right? How much sand is on the beach at time t equals 0? Okay, that was my initial value of 2,500, right? So that one's easy. If I plug now 5.118 into my accumulation function, my y of t is up above here. So if I'm calculating y of 5.118, I'm going to want 5.118 here and here. Since both of these have the same exact limits of integration, you guys can actually combine this as 2,500 plus, I'm on part B right here, writing it out, 0 to t of s of x minus r of x as one interval to make it just a little bit easier on you guys on entering it in on the calculator. That's equivalent. So what you're going to do is on your calculator, you're going to, on the home screen, you're going to have 2,500 plus 0 to, and instead, this is the important part. This was an intermediate step. Your calculator, your last calculation was 5.118. So your calculator actually stores that in ST or XT theta n, that button where you guys usually press for X, that's stored in that. So what you guys can do is just go from 0 to X on your calculator for your limits of integration and do S of X is y of 2. So y2 minus y1 on your calculator dx. Now on my actual free response, I would write the function s of x minus r of x. I'm just showing you guys that's what you guys would input on your calculator. So what, and actually I don't think they would even grade you guys on that step. They would just grade you on the answer for that. There should have been only one intersection point, just that 5.118. And then type into the chat, what did you guys get for that value? Okay, the ones coming through are correct. By the way, someone asked if there's 2 intersection points, so I just took a picture of my graph. The only intersection point I think occurs over here on the far right. The other one doesn't actually intersect. Okay, so the correct answer is 2,492 point, and let me erase that because that's a little bit messy there. 2,492.369. And then below that, we also have to calculate 6. So my recommendation to you guys is to hit second entry on your calculator on the home screen. Go ahead and hit second entry, and it pulls your last calculation up. And that way you don't have to re-enter the entire function again. You guys can do second entry and change your upper limit of integration this time to be 2,500, and we're accumulating from 0 to 6 of y2 minus y1. And tell me what you guys get for that. So do second entry. That will pull up your last entry, and then just change the x to be 6. And that's 2,500 plus what you have currently on your beach. Okay, good, Newland, that's correct. And because time is running over, I see the ones coming in through are correct. 2,493.277 is correct. And we would answer our question, what is the minimum value? The minimum value is 2,492.369, which occurs at time t equals 5.118. And your table of values is sufficient. Again, the only thing I would change, just because I'm doing this over Zoom, is that I wouldn't use what we call calculator talk on your free response justification. For Y2 and Y1, I would just call those S of t and R of t. I just wanted to input that here so you guys could see what the entry was on your calculator. But 2,492.369 is the minimum value, and that occurs at time t equals 5.118. All right, you guys, I will see you for the next class. And if you didn't get those answers or you need more help, let me